Hi guys, Greg at Panels R Us. In our last video we showed how to connect a colour light card such as this one to your P5 panels and get them all up and running with LED Vision version 7.2. Now that was in preparation for our next move, setting them up with Falcon Pi Player in order to play sequences from X-Lights. And setting them up with FPP is what we're going to do now using a Raspberry Pi. So I've got here a Raspberry Pi version 4. This one's in the official case. This is the smallest of the version 4 variants, so it's the 2 gig model, and that's plenty for what we're going to use it for. You can also use a Model 3B Plus, note the plus. Either the 3B Plus or the 4 have to be used currently because they are the only ones with gigabit Ethernet, which is what the colour light cards require. Now, in addition to the Pi, I've got an official power supply. This is 5 volts, 3 amps. The Pi 4 has a USB-C port for power, so you need to make sure you get the right power supply. The 3B Plus and earlier used a micro USB port, but the 4 has moved on to USB-C, so just make sure you get the right one. And I've got a SanDisk 16 gig micro SD card. It's a class 10 card, so you've got to look for a little bit of speed on these because there's a reasonable amount of data flowing backwards and forwards from the card. So we need one that will keep up. So that's a class 10 card. This one's 16 gig. For the prices these days, you might want a 32 or even a 64. They're not expensive at all. And last but not least, we need a piece of Ethernet cable with a couple of Cat5, a couple of RJ45s on the end. This is going to run from the colour light card to our Raspberry Pi and give us connectivity. Now, it doesn't matter which of the ports you connect to on the colour light, they both do the same thing, so we can plug and play on either. Now, for this configuration, we'll note that the Raspberry Pi only has one Ethernet jack, and we're going to use this jack to connect to the colour light. Now, if you want this Pi to be connected to your home network as well via wired Ethernet, then you need a USB Ethernet adapter, which you can plug into one of the USB ports here. That will then give you a second Cat5 Ethernet port that you can push back to your home network. But for this demonstration, we're going to be setting the Pi up on Wi-Fi. So it's going to connect to our Wi-Fi here. So we can then use that to talk to it from X-Lights, and it will talk to the colour light through the Ethernet port. When I say Cat5, it can be Cat5, Cat5e, Cat6, any of the standard ones using the 8-pole RJ45 interface. So first thing we need to do is to get FPP downloaded onto our laptop and installed onto this card. So let's crack on. Now, the first thing you're going to need is a method of plugging the micro SD card into your PC. Now, you might have a small USB micro SD card reader such as this one. I think this one came with a 3D printer. Or on my laptop, it has a full-size SD card reader built into the laptop, in which case we're going to use the micro SD card adapter that's been included with this micro SD card. So whichever way you're using, get the card ready. We'll get that out of this packaging in a moment, and we'll get it installed into the laptop, ready to go. Jumping onto the PC, the first thing we need to do is to download a couple of pieces of software. Now the first, of course, is Falcon Pi Player itself. So if we navigate to the GitHub page, I'll put a link in the description below. This is where we need to download from. The latest full release is always at the top of the page, and if we can see that is version 4.6.1. Now if I scroll down a wee bit, we can see that there are some assets on 4.6.1, and one of those is the one that we want. It's FPP 4.6.1 pi.image. So I'm going to download that now. Just click on that, and that's started to download. Now whilst that's cracking on, I'm also going to download a copy of Balena Etcher. That's the software that we're going to use to write the image to the Raspberry Pi's SD card. So nice and simple front page. There's a nice green box in the middle to say download. Now download obviously the version for the type of machine that you have. I needed one for a Windows x86 64. So I'm just going to start that downloading as well. There we go. So that's the two files that we need to download on their way. Balena Etcher has now downloaded, so I'm going to get that installed so we're ready to write our SD card. So just double click on it, and it's popped up a license agreement, so I'll just run through that. And there we go. That was really quick and simple. It's done it already. So a really quick install there. Now it's given us a few options. We can flash from file, flash from URL, or clone drive. So we're going to be flashing from file. So at this point we need to insert our micro SD card using whatever reader mechanism you've got into the PC. There we go. So that's given me a removable disk. I'm just going to close that window down. Now FPP is still installing, so we're still downloading, so we're not quite ready yet. So that's finished downloading. I can now close my Firefox window. Yeah, I'll get rid of that. There we go. So here's Etcher then, ready to go. So I'm going to go for flash from file. There's the zip file that we downloaded. We don't have to decompress the zip or anything like that. Etcher will do it as part of the write. So I've selected the image there. Open. Select a target is now asking us, if we click on that, it's asking us where we want to write the image. In this case I've got a 2 terabyte D drive. I don't want to put it on there. And I've got a 15.9 gigabit USB device. That's the one. That's our SD card, so that's where we're going to put it. And then I press select, and then we simply press flash, and it's now rattling along. So it's, as you can see, it's decompressing the zip file first of all, and then it will proceed with writing to the card. There we go. So that's one successful target. So it's completed the write, and it's then verified that it's done what it said it was going to do. So the image is now ready to be used on our Raspberry Pi. So we can close Etcher down and eject the SD card. Oh, there it goes. Ready to put into our Pi. So with our image written to the micro SD card, it's now time to put that into the Pi. So I'm just going to drop that into the SD card slot on the back of the Pi. There we go, that's in. Nicely done. And at this point I'm going to power the Pi up, but I'm not going to connect anything else. So I'm only going to connect the power cable to the Pi to get it started up. There we go. That's now plugged in, and we've got the red power and green SD card activity LEDs now happening. Now I don't want to connect anything else at this point. We're going to let the Pi boot up. As it hasn't got any networking configured, it's going to use the onboard Wi-Fi to set itself up with its own SSID, so its own Wi-Fi, effectively an access point. We will then be able to access that access point using a wireless device, be it a tablet, your phone, or a PC if you've got Wi-Fi on the PC, probably if you've got a laptop. You can then connect to that SSID, connect to the FPP instance, and we can configure it to add it to our conventional network. So that looks like it's pretty much ready to go. The green SD card activity light has gone out. It's just got the occasional flicker. So I suspect that that's now ready for us to move ahead and get the Wi-Fi set up. There we go. So if I now go down to my network settings, and we can see straight away that there is an FPP SSID available. So if I connect to that, and we'll connect automatically, we'll connect, enter the security key. Now the key for this is Christmas with a capital C. And no, we don't want that PC to be discoverable. And there we go. So it's now connected. It says no internet secured. That's fine because the Pi is only the one box. It's not connected to anything else, so I wouldn't expect it to have internet connectivity. So I'm now going to go back to my web browser now, and I'm going to key in the IP address of 192.168.8.1. I'll stick an extra dot in there. And there we go. That's our instance of FPP on its own Wi-Fi. So the first thing we need to do is we can go in and get the network set up. So if we go into status network, select the wireless LAN, and then put in, there we go, we've got a drop down with a list of options for available SSIDs, so I can select one from there and just put my password in. And then update interface. I'm going to rename this instance to FPP demo. There we go, so that's going to save that. And it now wants us to reboot. So I've just hit update interface, save, and that's ready for us to reboot and for it to connect to our normal wireless network. If you're outside the US, you'll need to change the Wi-Fi regulatory domain. Basically means that different areas have very slightly different settings for their Wi-Fi. They have a very slightly different range of frequencies allowed, so you get some slight variations if you don't select the right regulatory domain. So we've set that now to UK because that's where we are. We've gone into wireless LAN 0, we've set the SSID and password, we've updated interface, and we're ready to reboot. And OK. And the Pi will now restart. And you'll see that the FPP SSID will disappear and it will no longer be available. Now our Raspberry Pi should now have come back up. I'm going to type FPP demo into our browser, and that didn't find anything. So what we can do is we can cheat and we can use Xlights. If I go into Xlights, Tools, FPP connect. There we go, we've found it. So our IP address is 192.168.198. So if I put that into my, there we go, there's our instance of FPP ready to configure. Now the first thing I'm going to do is to pay attention to this red bar. We need to expand the storage space on the SD card. So we're going to storage, grow file system, yes. And once again it wants a reboot. So I'll press OK. So it should now be back up, I think. If we refresh the page, there we go. So the Pi is now back up and we're ready to configure our panel. So I'm going to go now and just plug in the Ethernet card from the color light, or the Ethernet connection from the color light into the Pi. There we go, the Ethernet is now plugged in. So let's go into the configuration. We're going to go into input output setup and channel outputs, and then we're going to go to LED panels. So starting at the top, we'll go through, we'll check enable LED panel output. Our panel layout. Now this is the number of panels wide by the number of panels high. So in this case we are looking at 2 panels wide by 3 panels high. We can ignore the red bar at the top because we've got more to go yet. So we're going to get more configured before we restart FPPD. Now our single panel size, we're looking at P5s, so ours are 64 by 32, and these indoor panels are 1/16 scan. You need to check on the back of your own panel exactly what the scan rate is. We're starting top left, and we need to change our connection to color light. The only other thing we need to change at this point here is the interface. We need to make sure that's set to ETH0 to make sure it's using the onboard port, and that's fine. If you had a USB wireless adapter to connect to your home network, you would see an ETH0 and an ETH1 in here. Most of the time it will be ETH0 that you want to use the onboard Ethernet port for your color light. Now on the Raspberry Pi 3B Plus and earlier, the Ethernet port on the Raspberry Pi was just a USB Ethernet card, but built onto the main board. So it didn't really matter which interface you used if you plugged in an external USB Ethernet adapter, because they were both USB Ethernet adapters, just one was integrated onto the board. On the Pi 4s, they have updated the connectivity of the Ethernet card, so it now has a dedicated high-speed bus back to the processor. So I would always use the onboard Ethernet on a Pi 4 to connect to the color light versus using a USB Ethernet adapter. That will run a little bit slower. Not an issue when we're just uploading sequences, but you want the maximum performance when you're driving your panel. Right, now we move down to, I'll just save this at this point. There we go. And it says channel output saved. I'm now going to move down to the configuration of the panels. So we've got O's, P's and CDFs. The O's are for outputs, so they're the ports on the color light. The P's are the panel number. So everything at the moment is connected up and labelled as output 1, panel 1. Now on our little panel over there, we have 3 outputs in use. We have output 1, output 2 and output 3. Each of them are driving 2 panels. So each row is based off a single port. The top row is running off output 1, middle row off output 2, and the bottom row off output 3. So I'm going to update the outputs. So output 2, output 2, output 3, output 3. And our panels, the colour light's connected to the right hand side panel first, and then it daisy chains across to the left. So we've got panel 1 and panel 2 when viewed from the front. So we're all panel 2s on the right and panel 1s on, panel 2s on the left and panel 1s on the right. So output 1 panel 1, output 2 panel 1. The CDEF is the colour order. If it's the default colour order, then that's fine. If you're mix and matching panels to make your matrix, then you might need to change that, but normally you wouldn't have to. Notice the arrows as well. You can click on the arrows to move them. On the back of all of the panels there is an arrow, and ideally you want to build your matrix with all of the arrows pointing up. So that is our panel configured in FPP. I'm just going to hit save again and then scroll back up and restart FPPD. This can take a moment if you've done a big change. So we're now ready to test this panel. So we can go into status control and display testing. And if we enable test mode, we have life on the panel. So that's brilliant. It's a little bit difficult to tell exactly what it's doing. Lots of pixels doing a chase. So if I change it to a cycle, we can confirm exactly what's going on. So we're getting RB, red, blue, green. Now it should be doing red, green, blue, so something's not quite right there. So we need to confirm our colour order. We can change the colour order at the top here. So if we change that to BGR, that's now going red, green, blue. So that's the way it should be. Now we can confirm that by doing a fill. If I drag all the sliders down to the left, stick it on fill, we can then enable red, and red is happening. We can enable green, and green is happening, and we should get blue and blue. So there we go. So we know the color order is BGR. You can test it here and make sure that you get it right, and then we'll go back into our channel outputs, LED panels, and change it here to the one that you ended up with. So BGR is the normal for P5 indoor panels. And I'm going to hit save, and we'll restart FPPD. There we go, so that's restarted. So we can go back to status, display testing. Our color order is now RGB, and if we test again with a cycle, that's now doing red, green and blue as it should be. So that is FPP panel setup complete. We're ready now to move on to X-Lights. If you're enjoying this video and you want to make something similar, don't forget to visit us at panelsareus.co.uk. And if you like the t-shirt, lttstore.com. Moving over to X-Lights then, we're going to use some of the more recent functionality in the form of the Discover option here on the Controllers tab. This will automatically probe our network and look for any instances of FPP that are running. So let's just give it a whirl. There we go, it says at the bottom we're running the controller discovery, and it claims to have found an existing controller with a different IP address. Well, we've got no controllers discovered, Notice controller's in here at the moment, so I'm just going to say yes to this. And there we go. So it's found our instance of FPP and discovered how many channels are currently set up on it. So we've just got the matrix configured, so it's worked out how many channels are configured for the matrix and added them in automatically. We now need to go into our layout tab and add the matrix to our layout. Now this is an empty setup. You may well already have some props on here, but for this one it's just a blank sheet. So I'm going to create a new matrix and drag it out roughly the shape of our physical matrix, so it looks better. There we go. So there's our matrix into the layout. We now need to configure that. So I'm going to name it P5 panel. The direction is horizontal. All the strings are going to be running horizontally. The number of strings is the number of pixels in the matrix vertically, so up and down. So in our case we have the three rows of panels. Each row is 32 pixels, giving us a total of 96. The nodes per string is the number of pixels horizontally, so going across. We've got our 2 panels wide, each of 64, so that gives us 128. Strands per string we can leave at 1. Starting location. When we were configuring FPP, we set the starting location in there as top left, so we need to make sure that Xlights matches that. Okay, so that's set for top left. Individual start channels we don't need to check, but start channel, if we click on the three dots button on the right hand side here, we can make sure that our controller is set correctly. So I'm going to go down to controller and set that as FPP demo, which is our Raspberry Pi. And that completes the configuration side of the matrix in Xlights. We can save that, and that is now set up, ready to go. So let's put a short sequence together and test it out. I'll just move the Xlights window over there, and then we can get another copy. We can get a video down in the bottom. So let's go for a sequencer. I'm just going to start a new sequence, animation 20 frames per second. There it is. We're ready to put some effects onto our panel. So I'm just going to drag the butterfly down. There we go. And there's our butterfly. We'll drag it out to 30 seconds. I'm going to add a second line to that, so I'm going to insert a layer above, and I'm going to put a text effect on there. There it goes. So we'll drag that out to the same length. And I'm going to put some text on, thanks for watching. That looks absolutely shocking at the moment because of the colours. So I'll make that all white. And I'm going to change the opacity of the background. So I've changed the brightness of the background down to 36. We've got our text on there. We've only got one thing left to do, and let's make sure that it works. So if I enable output to lights, absolutely nothing has happened. We are not getting any output on our panel. So let's go and have a quick look at FPP and see why that's happening. Okay. Right, so looking at FPP, I can see straight away that FPP is in standalone mode. So that is expecting to play a sequence, not to receive data from another source, i.e. X-Lights. If I put the player into bridge mode, that will then receive the data from X-Lights and will put it on the screen. And there we have it. So our panel is now working, FPP is set up, X-Lights is set up, and away you go. Now we're running this at the moment in bridge mode, but you don't want to do that for your show. Each 1,000 pixels, and each of these panels is just over 2,000 pixels. For every 1,000 pixels you use about 1 megabit of bandwidth, and therefore you can very rapidly build up to a large network overhead. For even a small panel this size, that's going to be running at about 12 megabits per second. Yes, we can do it as we're doing here for testing, and it's actually working very well at the moment. But for your show, you want to be saving the sequence and uploading it to FPP, and then running in FPP either as the master or as a remote, depending on your setup. But the packets, the sequence should really be run from the instance of FPP that's driving the panel. I hope you found this useful. Please do like and share, and if you've got any questions, drop them below, or find me in one of the social media, the Facebook groups, either FPP, the DIY P10 panels group, or European Lighting Fanatics. I'll be around in one of those, so please drop me a line, and we'll get you up and running. Take care, have fun, and we'll see you soon.